For our lesson number 10, we have the Truss analysis method of members. So the frames are structures with some or all members being 3/4 members. The method of members involves disconnecting each 3/4 members and writing equilibrium equation for its free body diagram. So this is our 2-point action member, which consists of forces AB, and as you can see at the figure below, the resultant and the 3-point action member is with 3 forces ACB, and the resultant occur both along and perpendicular to x-axis. So for our summation of F horizontal is equals to 0, and our summation for F vertical is equals to 0, and for our summation of moment is equals to 0. So for our problem, we have the frame shown in figure is supported by a hinge J and a roller at E. So compute the horizontal and vertical components of the hinge force at A as it acts upon JB. So we have here a force 27 kN pointing downwards, and our point J with a distance of 5m to point E, and our point A, since it has a hinge force at A, so we have to divide it into 2. Since we divide our point A into 2, this will be 2.5 and 2.5. So the first thing we're going to do is to moment at point J. So moment at point J is 27 kN moment to point J, which is counter clockwise times its distance is 3, so times 3 minus our RE, this is our RE, times counter clockwise to our J, so and their distance is 5, so it is minus RE times 5 is equals to 16.2 kilonewton. So for our force vertical, we have the 16.2, which is our RE. This is our RE equals to 16.2. So plus our RJ, reaction J, minus 27 kN. It is negative 27 since it points downward. So equals 0, our RJ is equals to 10.8 kilonewton. So for the second step, we have to isolate the beam JB. So we're gonna go moment at B, point B. So let's moment our point J, RJ, our RJ. Moment to B, clockwise positive times its distance is 5. So times 5 plus our RA. It is pointing upwards. So, and since we divide this into 2, this is 2.5, 2.5. So, RAY times 2.5. So, our RAY is negative 21.6 kilonewtons. So, our assumption for RAY is wrong. So, this is downwards. So, for our force vertical, we have our RJ, which is 10.8, and minus our RAY, 21.6, since it is pointing now downwards. So, minus our RBY, pointing downwards. Our RBY is negative 10.8. So, again, our assumption is wrong. So, this will become upward. So, our next step is moment to A. We're gonna moment to A to get the RAX and RBX. So we're gonna moment at point A. So let's moment our RJ, which is the 10.8, moment to A, clockwise to A, times measurement of distance is 2.5 minus our RBY, counter clockwise to A, times 2.5 minus our RBX, since it is pointing to the left. So our RBX is equals to 0. So since RBX is 0, also the RAX.